Many large industries such as petrochemical, energy, chemical reprocessing, coal, or public transportation require large amounts of fuel and power to function. All of the necessary components that allow these industries to thrive each pose a risk of fire or overheating conditions. If not properly monitored, maintained, or should unexpected external conditions occur, a small fire outbreak has the potential to become a larger issue if not detected or responded correctly. The most effective way to mitigate and prevent these disasters from happening is to have proper monitoring and response equipment installed. Within these industries, components such as cable tray networks, storage buildings, fuel tanks, and even power generators or batteries are necessary. These components are commonly in cramped or hard-to-reach areas, which makes monitoring these areas a challenge to employees. Safety personnel will want continuous data to monitor these areas and ensure that if a fire outbreak or overheating conditions occur, they are immediately alerted. In these situations, linear distributed temperature monitoring is ideal. With hundreds of completed projects and decades of field experience, Senkox has developed a distributed temperature monitoring system ideal for industries where even the smallest fire risk can become a large disaster. In this video, we will demonstrate the Senkox HSD system, how its technology functions, and how the system responds to a fire outbreak. All Senkox LHS sensors are made of ceramic material. This material produces a thermoelectric effect, which generates an electric voltage that the DAQ module acquires and translates into real-time temperature data. This ceramic material is encased in stainless steel, and depending on the type of sensor, also features an outer jacket made of Teflon or an outer jacket of braided stainless steel. Every Senkox LHS sensor type can continue to measure the temperature of the installed area up to 800 degrees Celsius. Sensors that feature the Teflon outer jacket may become damaged at 260 degrees Celsius. We will be placing each sensor type near extreme heat to demonstrate how the sensor functions under such conditions. We will be demonstrating with an HSD-T sensor type. As you can see, the sensor is currently measuring the ambient temperature of the room. We will now be exposing the sensor to a high temperature flame. Notice as the temperature begins to reach 260 degrees Celsius, the outer jacket begins to melt and catch fire. However, this damage does not prevent the sensor from continuing to monitor the temperature of the flame. At this point, the sensor's outer jacket has completely melted where the flame has made direct contact with the sensor, and the flame is in contact with the inner materials of the sensor. Even though the sensor is badly damaged, it has not affected the sensor's ability to read the real-time temperature and rate of temperature change. The blue Teflon sensor also features the same capability. After the outer jacket becomes damaged, the sensor is still able to monitor the temperature and rate of temperature change. Now we will turn off the flame and allow the sensor to go back to the ambient room temperature. As you can see, the temperature is now nominal to the temperature of the room. We will now demonstrate that even though the sensor is damaged, it will still read high temperatures of hotspots by re-exposing it to the flame. Here you can see, as long as the sensor is exposed to heat that is 800 degrees Celsius or below, the sensor retains the capability of measuring the temperature data. Due to the sensor's features and construction, this solution is ideal for industries with sensitive requirements. The advanced capabilities of the sensor, such as intrinsic safety, is valuable when monitoring combustible materials such as fuel storage, coal, or chemicals. Due to the sensor's durability, it is rugged enough for outdoor use or within mines, caverns, and conveyor systems. Additionally, in the event a fire outbreak is indoors, the ability to monitor real-time temperature data is valuable to control rooms or safety departments. Indoor fires pose a risk of obscuring vision and can be generally difficult for firefighters to assess the situation and respond appropriately. Having real-time data available will greatly help during the suppression process. Through decades of experience, Senkox aims to provide effective, high-quality heat and fire prevention monitoring solutions to ensure the health and safety of assets and employees. Visit our website or speak with a Senkox specialist today to find out more.